Hey guys, welcome back to science class. We're just going to do an audio today, no visual of me. So, um, I have been checking your online analysis, your Activity 94 analysis questions about natural selection and the giraffes. And I just wanted to go over a few things because some of you did amazing and your answers are really, really good. And I'm very proud of you just because you did that without a ton of time to ask me questions. But some of you kind of missed the point, and I want to make sure if you especially, got a 7 out of 10 on that analysis question that you understand what happened. So remember, natural selection, if you look at the definition, is that animals that are, or organisms that are better suited to their environment are more likely to survive and reproduce and pass those traits on to their offspring. So remember that that only happens if you have variation in a species. So you need your species to be different. If you look at this bullet point, if all the organisms are the same in a species, no one can be better suited. They would all fail or they would all do well. So like in the example of polar bears don't have very much variation. And if I were to search up pictures of polar bears and look at them, you probably wouldn't be able to tell much difference between them. So as the climate is changing, all of the polar bears are not suited to the environment. They're not really good swimmers and their fur is very heavy. And as the climate gets warmer, they're all kind of struggling. So if we want to see the polar bears become more successful, they would have to have something that makes them different, maybe less fur, or the shape of their paws would be different so they could swim better. Um, but the only way that that's going to happen is if there's some random mutation. The polar bears can't sit around and have a meeting and decide that they need to be better. They just either have a mutation that makes them better or they don't. So hopefully in a species, if you have this variation because of those mutations, um, certain individuals will be better. They'll have a trait that makes them better and they'll survive more and they'll have more babies. And then they'll pass those mutations down to their offspring. And so over time, what you want to see is the traits that aren't so great slowly start to die out. So that's what you were supposed to get last week. We are going to keep talking about that this week, but now we are going to look at camouflage. So we are going to kind of this week start to look at some other things that organisms can have that make them better suited. So remember as we take notes that you can pause me anytime you want if you need time to write. But my goal is that you set up your notebook just like you normally would in class. Activity 95 is called Hiding in the Background. Our challenge question is going to be, how do factors such as the environment and the presence of predators affect the process of natural selection? So how does an animal look and how can a predator see it? And how does that affect who becomes better suited? So we only have one new key vocab this time, which is the word camouflage. I think that you are all probably very familiar with that. But camouflage is not just coloring. It is color, texture, patterning, or a shape that allows an organism to blend in with its surroundings. So I'm going to show you some of those examples of different kinds of camouflage. So if you need to pause while you finish writing, go ahead and do that. Otherwise, I am going to move on. On the next couple of slides, I'm going to show you some examples of camouflage. So normally if we were in class, I would put these up on the screen and I would wait for you all to shout out at me when you found the animal. So this is obviously a little bit different. What I'm going to ask you to do is I'm going to put the slide up and then I'm going to say pause. And I don't want you to unpause until you think you found the animal because then I'm going to keep going. And so we'll move along that way. Some of them are a lot more obvious than others. But in class, we would have a discussion about why I had them on there, and I'll try and do that as quickly as I can. So here's our first example. It is a stingray. Now, obviously, the stingray is not hard to see. You can see that he's there. But the cool thing about the stingray is if you look at his skin, you can see that the patterning on his skin looks very much like the floor, the sea floor. So it's not completely hidden. But if you were a predator or you were the stingray trying to sneak up on a prey, it would be harder to see you on the surface floor. Okay, so that's our stingray. Take a look at this one. Go ahead and pause until you find him. Okay, guys, do you see the wolf? Do you see him? He is right here. Take a look. Now his fur allows him to blend in not only with the foliage, but also with the bark on that tree. So he's really well hidden. Not too many things are hunting the wolf, but it allows him to sneak up on his prey more easily. How about the lion? If you look at the lion, I am sure that you see him. Okay, his coloring is really important. The lions sleep during the day. They hunt at night. So the lion is able to kind of take a snooze and know that things aren't going to see him. You would probably walk right by him in the wild and not even know he was there unless he moved. So he's pretty sneaky. That color's pretty. I mean, look at that. That's pretty close. How about this guy? The great white shark. Obviously, you can see him. Not a big surprise. But notice that his belly is white and his top is like that gray color. The reason for that is if you are swimming underneath a shark and you look up at the sky, the sun is very bright. You know that if you've ever looked up at the bottom of a pool, the sun is really, really bright. So if you looked up, you'd be less likely to see him above you. And then if you are above a shark, you would not see him in the ocean. The only way that we typically see sharks is if their dorsal fin sticks up out of the water. Otherwise, when you look down into open water, it's very dark. And in class, I would always ask everybody if anyone has gone snorkeling before. Because if you've gone snorkeling, you know that when you look out into the ocean, it's like emptiness. It just looks dark and gray. And a shark would sneak right up on you, and you would not know that he was coming. Okay, how about this one? Do you see it? What you should be seeing is a moth. And if you look, here is his, I'll trace his, this is his wing. There's a wing that comes down like this, and then the other wing, and there's his body in the center. And if you look, you can even see these patterns on his wings that make it look like the holes in the leaves. So a moth, if that moth was sitting in a pile of dried leaves, you probably would not see it at all. And more than likely, neither would the birds or the owls or whatever predator is hunting for those moths. So they are finely adapted to being camouflaged in their environment. How about a snowy environment? There are actually two animals in that picture. Go ahead and pause and see if you can find them. If you've unpaused, you should have seen snowy doves. So there is one dove right here, and there is another one right here. And think about all the animals that you know that live in the Arctic. The snowy owl, the snowy dove, you could look at polar bears. They're all pretty white, and that allows them to blend into the snow. How about this one? Do you see it? That is an owl, and he's looking right at you. Here's one eye, and here's the other eye. You can even see his tail feathers coming down around the stick, the branch there. So owls sleep during the day, and this allows them to be very well hidden. Okay, how about this one? Here is the Arctic fox. And an Arctic fox, if you can zoom in on him, he is both orangish and white. So as the seasons change in the taiga, he's able to blend into his surroundings really well. Now here are some cool ones. This is the stick bug. That is an insect that looks just like a stick. You would pick it up and not know any different. This is called the leaf cutter. He looks exactly like a leaf. If you look, you can even see the veins on his exoskeleton that makes it look like the veins of the leaf. And then does anyone know what this fish is? It's a flounder. And so the cool things about flounders is look at their coloring. I mean, That looks just like pebbles. And notice, but he has both of his eyes on the top of his body. So normally where the fish would have eyes on either side, he has both eyes on the top. So he kind of swims along the bottom of the ocean or a lake if it's a freshwater fish. So that's a cool camouflage there too. All right, so why camouflage? Why are we talking about this? What does camouflage have to do with evolution? So I'm going to put a link for you. It's an example of what's called the rock pocket mouse. And that video it's about 10 minutes. So I want you to watch the video and see how camouflage can affect a population. And they're going to use the natural selection terms that we've talked about. And then I want you, after you watch the video, I want you to go and in your classwork feed is going to be an exit ticket. And I want you to take the exit ticket so that I know that you set up your notebook and you watch the video. And it's just going to be a quick 5-point thing, just so that I can see that you understood what you were supposed to see in that video. And that's it for today. So you should have set up your notebook. You should have watched the Rock Pocket Mouse video, and you should take the exit ticket. And then we will continue on with camouflage tomorrow. All right, guys, have a great day. I'll see you tomorrow.